Okay, we're going to look at this pendulum question, the next one here. A pendulum in a clock swings back and forth. So it swings back and forth. Usually the bottom swings, not the top. I just can't do it here. It goes back and forth and back and forth. Okay, the graph below shows how the distance from the pendulum bob to the center position when the pendulum is vertical changes as the bob swings back and forth. The y is the distance away in centimeters, and the x is the time in seconds. So let's just add that in here. So this is the time here in seconds. Okay. And over here, the distance away, I'm just going to write it this way. This is the distance in centimeters. Sometimes we call it displacement, but it's this distance away from the center of the pendulum. Okay, so that's distance away from the center, centimeters, time in seconds. It's a bit of a word problems. Okay, and then right here it says, what is the maximum distance from the center? So that's going to be our amplitude. So if you look from here to here, 5. Or you look at the bottom, it's minus 5 down here, but still 5. That's our amplitude. So 5, and our units are going to be 5 centimeters. So what is the period of motion? So let's see. We go from this to here, 4 to 8. See, 4 to 8. 8 subtract 4, we got 4. It's just one cycle. The period of motion is one cycle, so it's 4. So if we went from this head, or this top, this crest to that crest, you go 4. So the period of motion is 4, but we say 4 seconds because it's time. Okay, so instead of calling it amp, okay, instead put the second. So period of motion is 4 seconds. And the other one's the amplitude. Now, at what time is the bob 3 centimeters from the central position? So a 3 centimeter distance. So let's take a look. So 1, 2, 3. So let's see if I put a line across here. Okay, the first time it's 3 is right about here. I would say about, that's half, maybe 0.7. 0.7 seconds. Okay, now another time. Now look, at the bottom, it's also from the center, it's also 3 away down here. So another time is right there. That's the next time. So this is 3 away. Let me just show this. This is 3 away. But this down here is also 3 away. Okay, the top is 3 away, but at the bottom it's 3 away. So the next time it's 3 away. So passes the center, then it's 3 away down here. And that looks like about 1 point. We'll have to estimate 1 point. So that's 1.5. Let's say about 1.3. So that's 0.7. Let's say 1 point. There's 1.5. 1.3. I see the next one's 1.3 seconds. The S is for seconds, okay? So S is for seconds down here. The next one, so if we keep going, the next one is actually right here. And I say 2.5, about 2.6 seconds. The next time it's way up here, right about there. Okay, and that's 3.5 here. 3.3, I'd say about 3.3 seconds. Okay. Let's see if I got the 2.6, maybe 2.5, maybe 2.7. Sorry, stay consistent. 2.7. So look, we got that one to be 0.7, so probably 2.7, and that's 1.3. This is probably 3.3. So let's just stay consistent there. Okay, so at what time is the bob 3 centimeters from the center position? So we follow the 2 3s. The first one's about 1.7, 0.5, 0.7. This is about 1.3. That's about 2.5, 2.7, and that's, I'd say, almost 3.5, but 3.3. So we've got our different point positions there. So these are the points I looked at. This one, the little dots are. Okay, those are where those dots are. Okay, let's look at the next question. We're still not done. D. For how long during each cycle is the bob more than 3 centimeters from from the center position. So let's look at one cycle. So let's look from here to here. There's a cycle here. Okay, more than 3. So again, 3 up to here. There's the 3 down here, up to about here. And more than 3 here. So 1, 2, 3. 1, 2, 3. More than 3. So it would be from here to here, and then from the start here, and then to the end there. So it's quite interesting. So I don't know if I would shade it in. If I shade it in, it'd be all the way up to here. So right there, the first part, we already had that, 0.7 seconds. So, and then it's not 3 meters, so then it's close. Then over here at this, so from here to here, it's above. Okay, from here to there. So this would be number 1 here, the shaded area. This shaded area would be number 2. So that's number 2. So first 0.7 seconds. Number 2. So number 2 goes to 2.7 and 1.3. So you subtract. So I'll just put an arrow. It goes 2.7 minus 1.3. So it would be about 1.4 seconds. Okay, so for the shaded area from here to here, it's 1.4 seconds. Let's look at the third bit. Well, here it'd go from 4. It'd go from 2.7. What did I say? Sorry, it would go from 3.3 to 4. So remember the numbers we had over here? It'd go from 3.3 to 4 there. See, the first one went from 0 to 0.7, so that's just 0.7. The next one went from 1.3 over here to 2.7, so we subtract. Now we're going to go 4 subtract on the last one. We do 4 subtract 3.3, so it's 0.7 seconds. Okay, all this has to make some logical sense, because look, it's 1.4 seconds here, so it's probably 1.4 seconds on the top. So it'll be 0.7 plus 0.7 is 1.4. So when it's on one side of the pendulum, it's 0.7 seconds and 0.7 seconds, which is 1.4 and 1.4 down here. So if we add it all up, so we're going to add all these up. 0.7 plus 1.4 plus 0.7. So you're like doubling 2.4. You get 2.8 seconds. So for 2.8 seconds, the pendulum is more than 3 centimeters away. So a little bit of a trick one, that one. And the last video will show the last question.